Right. Ice back, day 9. Um, there's one thing that I actually wanted to do, which is a challenge. And me love some challenges. Let me double check something quickly. Yeah, that should be good. Close. All right. It was some really fun challenges, or what I've seen so far. On Windows reversing, I haven't done the exploiting yet. I don't think I can actually do this because I have no clue how this entirely works with, but they say it's pretty easy. And devirtualization, that's something that I really need to know. Some malware attempts to hinder reverse engineering by implementing a virtual machine which is run by custom bytecode. These challenges are designed by your test ability to reverse engineer and manipulate custom bytecode. Well, we'll probably do that. The only thing that I have no clue how or what. These are old challenges, what I've learned so far. I 2018, I believe. Yeah, that's been a while. Kinda hope that they would be more newer, if you know what I mean. Alright, let's do the first one. I kind of already did them, so there's just a couple that I didn't do, but just to go over it one more time, in which I will use show my folder, extract here, malware deck. Yeah, as you can see, those are from 2018. I wish there would be like more latest ones or something, like newer. Yes. Okay. Delete. I don't think I will stream. So, holy crap. I don't think I will stream like really long today. I have to get up early in the morning. Ugh. I'm getting really emotional up here. So emotional. Anyway, let's grab Ghidra. I always wonder how you pronounce, is it Ghidra? I hear so many different people on like how they pronounce it. I was like, why? New project. I've been learning a little bit more about how to work with Ghidra. Finish him. Okay, malware attack. Okay. Sure, you have access to my beautiful computer. Not a huge problem. Alright. Okay. Sure. Analyze it. I mean, why not, right? So there's a lot to learn using Hydra. First of all, I wonder if this can be in dark mode. Wait. Is there a dark mode? Dark theme installer? It comes with all the... Oh, there is. Question is how? I've been using Ghidra for a while now, but its default color scheme annoys me, especially when all my development tools and editors are running dark themes. While there's some support of recoloring certain aspects of the UI, not everything, blah blah blah. I was able to find one, but even left several dockable panels with. Okay. But not for the text reason. I have been able to extend that guy a bit further. And the process, I also modified the color scheme to my preferred one. Try and match the default dark theme from Visual Studio. Oh, I love that. Yeah. I choose Flatlav. It's my base dark theme, which you can find in the latest version of Maven. Once you download the jar, placing it into the Ghidra folder next to it, okay? Jesus. You would say that they actually like put it in like automatically for everyone. Makes it a little bit more easier, I'd say. Preferably, I would love to see it like the team like this one. Wait, it even has the music in there, listening to Zelda. Oh. Not sure what he's doing, but or he's reversing games. That could also be it. Oh, all right. Well, I guess I'll just leave it on whatever I have. It's way too much work. Well, this one is pretty easy. It is kind of obvious that the flag is up there. Basically, it's creating the base pointer stack or whatever it's called. Push the ECX, which moves the flag to EEX, which is on this line here. But if you do the patching, it's on this address. So if you search for this address, it's basically like seeing it up here. So flag makes it more obvious, but there you go. This is much better. If I am correct, you see like a reference up here and you see a reference up here, but this reference has two references, which is like, hey, what is this? So this reference to the, what's this called? Where am I actually in? I thought it's resources, I think. Looks like a resource. Yeah. Can I see where I am in? Oh. Pew, 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 pew. Which this is the flag. makes it kind of obvious. Jack flag, correct. Strings for the flag, perfect. So that was the easy one. That was the easy one. So they call the MD5 hash. They hash it, I think, at ESP4. Is that like zeroing it out, or calling it for the next message box that it needs a... We have been compromised. Okay. Flow override call return. Computed call terminated. Kind of like how smart this tool actually already is. Like basically saying like what everything already is. Like it. Don't save. Close. So got my first flag. Not that big of a deal. Let me download both of them here. Save. Save. Let me also download shellcode 1 and shellcode 2. Just to have it. All right, I am at the second string. Extract here. Malware tag. I'll rename this quickly. Yeah. Open zip. Hydra. The copy the string here. That's okay. Some information about it, like it's been compiled with Visual Studio and stuff. Okay. Open the string S2. Yes, I want to analyze it. Let's go. Is it done? Yeah, it looks like it. So got my symbol tree up here, which first you can look at the functions, or you can go to the import or export. You already see that it's calling MD5, so you would assume that's been calling the ordinal. Oh, that's for the I guess MD5 stuff. So let's just go to the entry and let's see what the entry has. Okay. So preparing a stack, saying that it might, I think this is like preparing a stack like how big it would be. So it's 40. Is it 40? Sure if this 40 is. Let's see. 40 lines. Yeah, close. If you, I think you calculate like the new whatever, leave some up. 40 characters, okay. Then put all these up here, local 2C, if I am correct. So local TC plus all the other 28 characters or minus 40. So all these up in EX. Okay. Copy that in. Can we see that here as well? No, not really. Interesting. Warning, subroutine does not return. So it grabs all this, but there's no code. Interesting. Right, local 8 is MD5 hash with local 2C, which is F up here. Why doesn't this show the rest of the flags? Which is okay. The pointer to local 2C. Well, it's not pointing, it's pointing. The end was, I believe, the value up in AX. Push that into AX and then hash the stuff. And then create the message box with everything in there. Which now is local 8, which is the entire flag. So it means that I have to click on every single of them, but that's gonna be a lot of work. That's gonna be a shit ton of work. So I wonder if there's a script, which is gonna be on Google, which is stack string Ghidra script. Decompiling stack string in Ghidra. In this post, I'll be discussing a method I recently implemented to have a stack string show up in Ghidra decompiler window. The final script transformed this garbage into significant better garbage. I like it. That is a lot of shit in there, to be honest. Couldn't write a local update JSON. Okay. If you have seen my Medium, you know that I like looking at Spotify binaries. I continue the trends recently since I have a problem with skip tracing project. Every so often I would notice that it wasn't getting new skips recorded from the macOS client, so I ran the OTool and my skip tracing whatever. My eyes are itchy. Give me a sec. Let me turn off the heating system here. Done. Okay, so after some investigation, I came to the conclusion that my Spotify must be updated itself in the background and overriding the binary. This was supported by the fact that I had a IDA database in application blah blah blah. This appears when I skip the stub. Well, Spotify is probably just wiping the whole directory. Anyways, I begin to investigate functions that are reference interesting updated related strings. To my horror, I saw the A forever reference stack string. This is technically isn't a stack string since the pointer is allocated by using new, but I'll just be calling them stack strings since it's easier. What is the boost C++ bullshit? I actually don't know. A good reason why this wouldn't be up to non-malware. Jesus, I can't even pronounce the word correctly. Non-malware. Seriously, if any knows, email or tweet me. Hopefully I'll be rewrite this blog update process soon, but for now I couldn't live with myself if I let it in the decompiler. Let's squash this. Yeah, this is a lot of stuff. JSON, right, couldn't. It's made a bit harder to read with the Galaxy Brain renaming registers. So let's step it up. Move. EDX30. Allocate. New operator. Okay. Some C++ bullshit. Yeah, I get it, but a gentle introduction to P-code. Okay. P-code Jira is registered transfer language. This means that the operator like load, store, add, etc. all take just their inputs and registers. Say registers quote. Okay. Since it is still important to know whether or not data is in the machine register or RAM, each P-code memory location, known as far node, has just an associated address space. This address space represents where the memory is located, like RAM for RAM register for machine register, and const for a immediate value amongst others. Take a look at your Ghidra docs. And of course, it's not there yet. Now that we know some kind of P-code, let's look at the P-code string building instructions. I wonder, P-code enable. Okay. Let's deconstruct two instructions pictured. Move rex invalid. This instruction is translated into a single P-code copy operation. Copy you might expect copies of the memory specific by var node and the RHS into the var node into the LHS. We now get a good look at the var node represented. For example, the destination of copy rex is represented as registers. Okay, this illustrates how how each var node is basically a 3 tuple composed of an address space offset size. For rex, it is a machine register, so it goes into the register space. It is also first registered in Ghidra process definition. This is the Jesus, they're words. It is offset 0, and rex is a 64-bit register, so the size of the var node is 8 bits. Okay. Move. So we see a lot of these list instructions and actually translate into 3 P-code operations: int, add, and copy and store. Int, add, copy and store. Yeah. Kind of what this does as well. First we have blah blah blah, the int, add operation, blah blah blah. Well, you know what. Detecting stack of strings with P-code. To detect recover stack strings, we emulate the function semi-symbolical and then detect copy of long ASCII strings followed by a store. Here's a GIF simulating the store for can write it up JSON. Okay. We start initializing with a Python dictionary register unique var code. Our var node is in the const space. We can just take offset. Otherwise, we hope that the previous stored. If this is not, then we have to evaluate the var node symbolic like rex. For example, above, we now have to keep a track of the register name and of that register in the same output var node, e.g. Okay. So patching stack string. We need to do something where it's obvious to Ghidra that we are moving the string into target register and offset with better calling string copy or plan. Write the string into memory, call string copy with or rec plus of destination string source. This thing will be a little bit tricky when you consider where to place a string. Okay. We have a whopping 1 byte, blah blah blah. Here's a link to the code. Two years ago, okay. A lot of code. Let me see if this is the only tool that I actually need. Import binary math struct. Basically copies everything. And this is not what I actually look for. So, too bad, Jose. Simple stack string. Okay. Yeah, this is what I have. Reassemble the stack string, form the repeat function of. So this has a lot of repeats, or like this. And an issue. So what it does is, okay, got a lot of stack strings and then put it in there. And then post it out what the entire string is. Well, that looks simple. Simple stack string. So. Okay. From Ghidra program model listening import code unit. Script name is that. Okay. Listening current program get listing. Text string is 0. Inst is get instruction at current address. So that means that I have to click only on the address where I want it. Disable field. While inst and inst get scalar or inst get scalar is 0, if inst get scalar is non-value get scalar value, else value inst 1. I need to figure out how this works. Fix me, there's a bug that no bytes are dropped. Okay. While value is get next script name. Okay, let's try this out. So we copy the code up here. Go play. Click on the play button because that is where all these scripts are. Of Ghidra. This is gonna be a string. So I'll add a new Python script up here. Stack string. Okay. YouTube. Save. Okay. Gonna start up here, so it's gonna be my first move. Play this shit. It's eating it up. And there you go. Simple stack string, simple stack string. Yes, that's the word that I was looking for. Not the sex string, but the stack string. Yes. There we go. Stack strings are the best strings. So if I go back to the website and I click on this one and I'll put the flag in here. Correct. Flag for string 2. Nice. That's pretty cool though. That it just calculates everything. Really needs. Okay. Damn it. More things to learn. So if I want to go more into this and more learning and programming, then I also need to understand how Ghidra works to automate certain things. I know Ghidra can get into headless mode, so you can actually use it for a lot of things. Or maybe I can do something that I just select everything that I want from this to this and then iterate over it to grab it. We'll see. We'll see. So, another problem solved. We got it. We got this one as well. Don't save. That's fine. We're going to string 3. Extract here. 7-zip. Extract. There. Tag. Rename it. Yes. I've not even executed them, so that's good. All right. Let's see what Windows reversing 3. So it says it's a little bit more difficult, so we'll see. Ghidra. Open. Okay. There you go. Dun. Yes. Analyze. So it does a couple things in the background. So we're going to find the main or the entry actually. The entry in here is it's pretty simple. It's just like up here and then you're done. I should put in more of these data types actually. I just downloaded the Windows 11 version. Okay. So nice. I got some little bit of code here as well, so I can check that out. All right, so it's preparing the stack. It's a big one. Load effective address 9C. What's 9C going to do? I don't know exactly. So the address EBP plus this. So this is where it starts, I think. It's weird. So we go MD5, so it's doing something with MD5. Move basically 0 to the stack. So clear it. Push. How much is this? And push 0 and then do something new and then empty DLL. I think this must be like the compiler already does. I don't know. Clear. And this is interesting. Get the source. So find resource A. Find resource A. I believe find resource is you call those things. It's not in here. God damn it. Or is it? Yeah, it is. It is up here. So there are resources in here. But the question, so everything has an ID, but there's so many that I do not know which resource is gonna be it. All right, go back to the entry. So find resource A, which, let me see. MSDN. Oh. Find resource function when base determines the location of a resource within a specific type and name in a specific module to specify the language use find resource X function. So we got the H module. It's up there. Then it basically says like where it's grabbing, and then I'm not entirely sure what this means. The resource type alternatively rather than a pointer of this parameter make where ID is given resource type for standing the types. Okay, it's an macro. Converts an integer value to a resource type compatible with the resource manager function. This macro is used to play string containing the name of the resource. Okay. And the resource type. How do I compare 6 with the type? 9, 21, 22, 6. Okay, so I got some up here. 8, 7, 11. Make it in resource. So we got the string and the version. So wait a minute. So string and version. Does this mean that the ID is... So we got the string and the version or ID. Is this? Oh, so this is a string. And this is the ID. So it's trying to get the ID, and the ID is 110 or 272 in decimal. Yeah, because this up here, the load string, which already gets the information, but also has 110. Load string, MSDN. MSDN. Loads a string resource from the executable file associated with a specific module and either copies the string into a buffer with terminating null character. Okay. Or returns. This isn't. Huh. So we got the H instance, which is basically 0. Then we have the out. Do I say this correctly? Oh, it's accepting 4. Oh, this is the ID. Okay, so the ID, what I want is 110. Then we have the buffer, which is this. And then we have the other buffer. So 110. So resources are popular. So this is the flag. But how would you do this if you don't have this? Okay. X and blah blah. So it starts up here. It just says that EX, so 0 goes into EAX. So move that into EAX. Then shift left. With 08. So shift left. Calculator. My best friend. Programmer. Okay, so we put 1 into EEX. And then we shift it to the left 8 times, which is 100. Then we clear the... So XOR EDX is clearing the register. So inc EDX, so that means there is 1 in there. And then shift left EDX with 04. So 4 shift lefts of 1. So we got 100 plus 4 shift 1. Wait, that's not correct. 108? No, that's not correct. Let's do that again. So we shift 1 into EX and shift that 8 times is 100. Then plus 1 shift left 4 is 110. Yeah. Or yeah, so EX and EDX, or I believe they basically like sum that up together, but they use an or. Let me double check that in. Assembly or or operand 1 and 2. Yeah, but that's great. Processor instruction says provides the instruction and or XOR test and not Boolean logic. Yeah, that's fine. I understand that. Or instruction. The OR instruction is used to support logical expression by performing a bitwise OR operand. The bitwise OR operand returns operation returns 1. If the match bidding okay, so I did a plus, so I guess that is somewhat correct what I did. So 1 1 is 1, 0 1 is 1, 1 is and 0 is 0. So technically why is that? So I had 100 and then I got 10, so 0 with nothing is 0. Wait, is that no? I need to do it like this. So 0 0 is 0. 1 1 is 1 and 1. And decimal. if I put this in decimal, is 272. So this is how you calculate this little part up here. Push size, I believe. And then EX goes into EBP, which is up there. So the effective address of whatever this is. I think this is because oh, this is still the load string stuff. Yeah, it's still the load string stuff. It's just like getting the extra data up here. So EX is local 4A4. Put this. I'll start from there. Grab that, because that is the string that I just posted up there into the stack. Put it in EX, push EX, and then whatever this is, put that in 9C. So 4A is what I have. And then basically post it because of the MD5. So my flag is this up here, which is not fully, which I can actually go to. I wonder, resources up here. Is there no like a better way? I need to find 217. No, it wasn't 217, right? 270. Okay, a little bit up here. There you go, and you can also see that it's correct because Ghidra already made a entry for it, which is good. Copy this flag, go to the entry, and the entry is basically up here. Can I just not click on? No. Interesting. So if I am correct, this should be the flag. And I got the correct flag. Nice. So these I can do, which I fully understand how this works. Let's see if I can do shellcode 1 as well. And maybe 2. 2 is a little bit more difficult, but I still have no clue about the virtualization. I guess I need to read up more about that. How that works. Ransomware, I like, okay, create my own crypto. Or actually like reverse engineering the crypto, never roll out your own crypto. As a result, sometimes it's possible to recover the encrypted files without paying the ransom. These challenges are designed to test your ability to recover ransomware encryption data. Okay. Let's do shellcode first and see how that works, because I have no clue. One. Show more options. Let's have a zip extract here. Malware tag. Shellcode. Yeah. Yeah, leave this all open, that's fine. Bum. All right. Shellcode 1. Okay. Okay. Open it. Yes. Analyze. All right. Again, let's go to the entry of the file. I believe it's not that bit difficult to get the entry. So again, it is get heap process, string length, virtual alloc. Okay, and this is where I am going to fail a bit because I don't know how or what. All right. Again, stack shit. $160. EX in local, or put the address into EBP, put local 8, get the address and put it back into EX. Okay, this is weird. That to be not entirely sure what this is. To be FL A no. Yeah, it doesn't show anything up here as well. The strings. So this is interesting. So this one I think as soon as I know how this works, I'll be like, oh yeah, easy. So finding strings is really, so move. So it puts this into EEX, then pushes it, and then calls the string length. And then put EBP local 8, which is, I believe, this. Into ECX, EX, push, call, kernel, virtual alloc. And then hash it. So I guess I put it into memory. This piece of whatever this is. This dead. So they allocated it, then they move it into memory, which is basically like, I don't know. And then as soon as they have the string, they MD5 hash it and then basically put it up here saying like, hey, we have been compromised. After this, where does the... I am wondering. So push into ECX. And they put the output of EX, what MD5 did, into local A, and they call local A to push that and print it in a message box. So local address. I wonder if this works. Let me... So if I push this, I get the MD5 hash of that particular string. Push. Not entirely sure what this actually does. EBP plus whatever FFFFFF868. It goes to that, but so yeah, that points to copy. Just want to make a copy out of this, okay. And I'll ask... Wait, let me first... Oh, I don't have to. I have a copy of there. Patch the instruction. Leah. And give me this memory address. What's up there? So that still looks good. Oh, export program, which is gonna be called patch. There's gonna be a PE. Okay. Let's see what this does. Ah, damn it. Why you no save? Patch. Not on here. I want you in downloads. Document downloads. Select. Okay, patch. Nothing. So there is nothing in there. Okay, so that didn't work for this case. Functions. Oh crap. Shellcode. Analyze. Entry. Which one? If you put in there. Okay, so cool. There we go. Okay. Google shellcode. Ghidra dot do I say it correctly? Yeah. Huh. Okay. Someone already did it. Well, then I am wondering if I'm correct or not. In the event of my first really exploring Ghidra, which is free reverse engineering tool developed by the NSA, I decided to solve this reverse engineering challenge with it. It almost has the features as IDA Pro, but it's free, which makes it awesome. When is it posted? 2019, okay. I'll start by loading the executable in Ghidra. The tool thing about Ghidra is that we get the decompiler for free, which is allow us to view the pseudocode of the assembly, which looks like blah blah blah. Isn't that nice? We immediately get the pseudocode, so we don't have to go through each assembly instructions. It is good to understand that the assembly instruction too, but anyways, let's dive into. I'll focus on the decompiler with bare with line 5 to 20, just defining the variable or variables. Line 14 is taking the MD5 local C9. Then in line 17, the output of get heap process assigned by the heap heap. Then in line 18, right, that's what I said as well. It receives the handle to be the default heap of calling a process. These handles can be used in subsequent calls of the heap function. This function does not take any parameters. More details can be found at the official document. So, okay, at the heap process, let me double check that on the receive the handle. This handle can be used. Okay. If the function succeeds, the return value handle of the calling heap process. If the function fails, it returns as null. To get the extended error information, get last error call. Okay. Interesting. Okay. Handle for the calling process. A process can be use this handle to allocate memory from the heap, on the process heap, without having to go first create a private heap using a heap create function. Heap allocate allocates a block of memory from the heap. Okay. Allocated memory is not movable. This handle is returned by the heap create heap process heap function. Since we already know the values of the dv bytes and dv flags from line 15. Right, so it's 10 bytes and no flags. Or 16. Oh yeah, 16. Jesus. Learn to count. So 16 is a function understandable to use, so it's heap alloc 0. So 16 bytes. More details on heap alloc can be found in the official document. The following blah blah. The heap from the memory will be allocated for now. Let's keep it like the code. The handle is the flag heap allocate options. Now that we know the flags is 0. If the functions succeed, the return value is a pointer to the allocated memory. So the return of this function is, and if it's true, wait, let me grab here quickly. Keep alloc, and then yes. The decompile label L8 makes it easier. This function is easy to return the value. The return value is a pointer to the allocated memory block. So point where 8 is, and this. So the return of the function is a pointer to allocate 16 bytes. The decompiler labeled as local 8 will be labeled, I will label it as 16. Make it easier. Yeah, okay, that's what he did. So rename basically says like 16. Oh, you're not doing it. Why not? Why do you not want to change? The decompile label is allocate 16 bytes. That doesn't matter. Then after the allocated 16 bytes, allocate 16 bytes will be filled whatever is stored at, yeah, which what I had as well. The letter H at the end of each string indicates that it's been hex format. Full content are, I wonder if Ghidra get shellcode plugin. Guide to scripting development of malware. I don't need to read that. I think I need to make something like that just to grab the whatever. Oh crap. Okay. So then the var1 is the length of the dat44, which is 40 in decimal, including the null byte at the end. I'll rename len of 40. Then comes the next function, function 3 on line 22. With the standard, oh. Reserves the comments changed instead of region, virtual address space of the calling process. Memory allocated by this function is automatically initialized to 0. LP address stars the address major region of the allocated in the memory is being reserved. The specific address is rounded down to the nearest multiple of the allocation granularity. If the memory is already reserved and it's being committed, the address is rounded down to the next page boundary to determine the size of the page and allocate granularly. Jesus, the words people use. On the host computer, use the get system info function. If the parameter is null, the system determines where it's allocated the region. The parameter is null, so the system will determine if the allocated is the region. No problem. It's 13 or 42 bytes. The type of memory allocation. The value being passed here is 1000, which is the official document say of that value. Memory protect for the region. If the pages are committed, then what the? Make medium work, we log user data by... You will never log me! Ever! Just let me read. Alright. The memory protection for the region page can be pages committed. Memory. The memory consent is 40 x40, which can be figured in the side. Read write. Something could be going on here. If the function succeeds, the return value is the base address of the allocation region. The page of the pseudocode is called destination, but it will be renamed to allocate 13 bytes for clarity. So memcopy. So memcopy everything. Copies between buffers. Okay. The function is copied. And replace it to allocate 13 bytes. This is what that is. The 13 bytes are blah blah. Now comes the fun part. Okay, that's where I was a bit stuck on. Function allocates 13 bytes is called. What on earth could it be? The instruction even look gibberish. But Ghidra let us disassemble it and found something juicy in there. To disassemble it, just right click on the whole code. You want to disassemble, right click and then disassemble. Wait, what? So that for... You click on everything? Or am I doing that correctly? No, this could not be. Up here, disassemble. Wait, what? Okay, let's keep this for later. Then on line 25, I see. So it is doing a loop with everything what I have. So shift bit 5 and then to the left and then you have to the right. So is this SOAR? Am I correct? I don't know. So 25, then do everything in what is in 4040. Then take 25, the MD5 hash of the content of blah blah, and storing it in local C, which rename to mstacks. It will also rename 25. Here's what the final renamed use looks like. mstacks. And that for now we know that allocated 13 bytes which contain that is being run would be analyzed that. Here's what the assembly code means. So move EDI, so ESI, so moving ESI to far init. Rotating 5-bit EDI will make a loop. You know that EDI is ESI, but what is EASE? Ghidra gives us a tool which can highlight the assembly code. And the pseudocode make highlight first byte, so the address is, which then could be assigned to MD5 text, which is our flag. After the Python script to perform the left rotation, which you can find here. So mass rotation. So format address, well, the 16 byte, which is for which then will be assigned to MD5 text, which is MD5 flag. So that's that. Yeah. Local A4. So this code, put it in the ESI. All this. Wait. Oh, nope. So there's a little bit of EDB code. Five rotations. Where's the 3 coming then? Rotation. Return a given number of bitwise left rotation in the integer n. So it gets the entire string rotation and width is 8. Where's 8 coming from? Trying to understand a little bit up here. So I understand rotation 5, which basically roll says here. So do that like 5 times. I believe even if I put in the function graph up here, you see this thing up here is basically do it 5 times. So if this is done, then return. The code prints 32 value hex bit. The role instructs is to convene. The nibble is the highest to the lowest order. Consider cafe dude. To print the first four letters out of it, you need to extract the values cafe. In order to do this, as you can see, the sequence move. Close nibble. Where does 8 come from? Like, so you say in pseudocode sync the highlight versus vice. So the address blah blah allocate 16 bytes, which is dot, which then should be assigned to MD5 text and flag. I craft a Python script to perform left rotation, which can also be found here. Right. Basically, it's like he's saying like game over right there. I'm just wondering where he comes up with the 8. Set a code. Okay, Python 3. Python has a variable length using the implementation requires the fixed width integer. This we can get by n values with the mass one by sufficient length below in combination with the mass 0. I struggle a little bit with this. I craft the Python script for a left rotation. So this is right, this is left. So shift the bottom, shift up, and mask. Move the top down. Okay, I get that. But where comes the 8 from? Because I only see 3. So 5 I understand. Is there a NIM version for this? Slate, Java, NIM. Wait. Or has this been changed? Oh, the code is totally the same than what he has. Here's what the assembly code means. Still doesn't mean rotate left 5 bits of each EDI. Right. This will loop. Yes. We know that EDI is ESI, but width is ESI. ESI. That's the 16 bits. Which is this. I only wanted to figure out where the 8 comes from, which I don't really fully understand that. I understand this. And it has been rotating 5 times. Rotation is smaller than 1, so the 8. The problem is that rotation is 5. Is that 8-bit width? Is that the bit operand? I think so. I think so. But then it says there are 3. Okay. So that's bit the width. Yeah, I think that's a bit. Interesting. Okay. Okay. I think I get it. If not, I can always do what else. Right. And if I have the results, um, 440. Move ESI. So if ESI is up here, is it being stored? Local 8. Run the shell code. Where does it save though? Turn with that result. I think that works. With patching. Okay. So it loads this. Then this goes into that, where we have the entire string. Goes into EDX. But it's not possible. Oh. When is this being executed? So memcopy everything. And right now I'm going to experiment a little bit. It clears it, I think. So EDX. Hey, Northern Dev. I'm doing fine. How are you? And thank you so much for the follow. Pretty good. Nice. I'm doing some of the malware tech flag thing. So I've done the first 3. I'm on shellcode 1, which I am a little bit trying to understand, and I got a little bit stuck. So I kind of looked for help, which figured out that the shell, this is the shell code, does the calculating of this up here. So I got the roll code, but the person, and I'm not sure if you can help me or whatsoever, the person that wrote this, his own script, says so you have the roll, which you have the rotations of 5, that I fully understand, which it says right here 5 times. The only thing that I didn't really understand is the width of 8, but I think the width is like 8 bytes or bits, 8 bits, I believe. Yeah, so just to let you know, I'm just like learning, and in the end of next year or in the beginning of next year, I want to be good, really good in reverse engineering, or fully understand so much that I can work things out. So yeah, that's where I was like a little bit looking at. So for the rest, I fully understand how it works. It was the only thing that I'm kind of confused is like, okay, how did he knew that it was like 8 bits? Because if you look at it, everything has been written pretty good, and then it's like game over. It's like, okay, so he got it from Rosetta. But even here, I am kind of like flabbergasted where the width of 8 comes from, because I would understand, or I would think that it will be somewhere up here as well, that I could see like, okay, that is 8, the width. And that's the only clue that I haven't figured out. So I was looking at it, and then there was like, okay, well, you have like different types, like 8, 16, 32, and 64 bit. So that's the only thing that I could actually think of, like, okay, so that must be the bit. So IFR 3. So this is the loop. And do whatever with PFAR1. And then this is the counter. And if it's 0, we're done. And that's the ESI, and the ESI is this bit up here. So oh, wait a minute. 32. 1. No worry, no worry. Wait, IFR is 1. Anyway, okay. I'll come back to this. Let's try to do shellcode 2 now. Let's see if that works much better into my advantage. Let me see. Show more options. Extract here. Delete this one. Rename it. Yes. Let's close this a little bit. So how have you been doing, Northern Dev? What are you programming? What are you doing these days? There we go. Okay. All right. Shellcode 2. Let's see, what is this? Yes. Analyze. Click. Functions entry. Oh. This looks like... Ah, Ah, mobile app. Nice. Okay, this looks like... Should this be the shell code that I was looking for? Let's see what this does. Keep alloc, so it loads library A, which is where is this? Local 8. EX goes local 8. What's the app about that you're doing? Okay, let me start from backwards. So we have been compromised local C. So local C goes, that is the digit up here. VP. Push 40, push. So I actually think there's local BC is the string that I am looking for before it goes into MD5. This one. I think it is. So ECX EVP. We've been compromised. D word EBP in local 8. So this is all getting into the memory, getting the shell code to run. This is the shell code, if I'm correct. This is technically doing as the stack string from the strings. And instead of that, put it everything into up here, stack string for the shell code. Get the heap process, get the like whatever. Then I believe load library. EX, which is, this is in EAX. Copy that. Copy that into EAX again. So move it back. Then load library in ECX. ECX is the word, so I believe it gets the same thing that I have with the strings. Virtual alloc. Allocating the memory. And we have the click. That is a lot, to be honest. The app supports documenting animals near building sites, which mandatory in Germany to preserve the ecologic environment. Oh. Okay, that's nice. So, I think this is the string that I need. So I'm gonna do the impossible. So I'm going to copy think I need just the stack where it is on the base stack. Then I can move this to EX. So I'll go to fetch function. That's right? No? Oh fuck, I fucked it up again. I messed it up again. That should work. Copy. Is it edit? Well, I'm not sure if it should be the word pointer, but we'll figure it out soon enough. Exit the program, which is I am going to be on home, download, shellcode, fetch, which is gonna be not that actually. It's going to be PE, which is going to be fetch, select output. Okay. Nothing. That's a string. I think I did something wrong. Because technically this should work. Oh, because I didn't put a LIA load effective address. I just moved it up there. Patch the instruction. Wait. Patch the instruction. LIA. So, load the effective address of this address, which is this address, which basically everything up here should have put the flag into the base pointer to this whatever, where that is on the heap, if I say this correctly. Once I've done that, I'll just basically copy this. So basically I say like, okay, whatever is on this address, put that into EEX and load the effective address, which is LEA, which is that I can put, and then it should be put that into the message box. So if I'm gonna save this as PA shellcode, okay, override it. Hopefully it has been overwritten, else I have to do it again. Patch, which I think I should do it again. Ah, crap. I have messed that up. It's not shellcode 2. Select output. Okay. It's not grabbing it. Where's that local 2C? Am I doing it wrong? I would not be surprised if I... Oh, wait, am I not grabbing the correct one? Which now I should fetch the instruction, which would be then minus 0.8 of x to 8. It's in this one. Home documents, not documents, download shellcode 2 underscore patch. Okay, overwritten. Okay, there you go, that works. Nice. I had the wrong one. Yeah, because this is really stupid. I should have looked at up here 2C. So it is actually saying 48. Yeah, so it's up here. So LeFX, so it puts everything what's an EBP, so EBP local 8, which is putting it into local 2C. So this is the stack or where it starts. So and local 2C, this is where it starts. So this is what I had to copy. So after patching that, push to EDX. So copies to EDX. ECX. Close this one down. Local 8, MD5 init. Yeah, so this is making it MD5 hash. Oh, what the hell did I do? Did I mess this up? Okay, so this is what it is. It is what it is. If I've done it like this, right? So I've been calling this stack up here, and I put that, so EBP with the stack, which is basically, this is local to C. Can I change this? I don't know. Oh, I've been clicking on things. This makes me wonder, though, if I'd done that. Don't. So I got my flag up here. Let's go back to shellcode 1. Yeah, okay. Which is basically or somewhat the same. So it calls this. Would it be no. No. Mm, 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 mm. Oh, I do have this installed, right? X60 32 dbg. Open, download, shellcode 1. So got the entry point. Ghidra. Let's see up here. So F. And kind of here. Okay. Run. Yeah, shellcode isn't just for exploits. Which, without doing much, puts it in the ESI. So it's in the EBP -4. EBP -4. This is where the shell flag actually is. Not in the 98. So if I just wonder. EBP -4, EBP -4, EBP -4. Is this? Before the call. So it's moving. Copy. So EBP local 4. I wonder if I would patch this. So I'm gonna just patch this to load effective address. Oh shite. Leah. And I will move this to local. EBP. Nope, it's plus. Where does it put that? Is this not possible? Edit. Patch. Copy. We have been compromised. That's instruction. And let's see if I save this. Shellcode 1 patch. Select. Okay. Ah, it's giving me crap back. Or am I doing it wrong? Yes, because I haven't put it in load effective address. And just remove this a little bit. So, load effective address. So EAX MBB, which is this, which is gonna be local A4. Save. Which is gonna be fetch. Select, okay. Overwritten, yes, okay. Ah, that doesn't work. Is that because EDX? Oh, push EDX. I think it's clearing it. Wait, no, it doesn't matter. I kind of hope that it worked, but I guess it's not. It works for the other, but not for this one. It's kind of cool that you can actually see, like, okay, what has been patched. Let's refresh this again. Let's go to the entry point. We have been compromised, so let's do some step overs as well, just to see what happens. Okay, it calls the shell code. Oh, shit. Let's step over. Entry point. So it calls the shell code, and then puts it in the, or gets the heap going, grabs from EVP, runs the shell code, or not. Yeah. Then it calls the shell. So why would you do it 2 times? Shells isn't just for exploits. It puts it on the APP4, which whatever the address there is. Which is in the ESP. Oh, that is the shell code. Oh shit, I clicked too fast. And then corrects it. I wonder if I can patch this. Let me put a copy, and there we have it. So, oh, the ESP is gonna be overwritten, right, from here. Yippee. So clear. So it is still in the ECI. Kept it loading up there. Let me see something. So ECI. Can I not just like load effective address? No. Let me see if I can Google this. Leah, assembly, Leah, ESI. ESI? Is that possible? Wait. Instead of asking the patch instructions. ESI. Okay, that's not possible. Is this possible? Oh. Exit program. Alright, Northern Dev, sorry I haven't looked at it, but you have a great night. Home. Documents. Shellcode underscore patch. Select output, okay. Override, okay. I wonder. Would be really bad if it works. Nah. Would have been funny, or I am doing it wrong. Wait. It's an N sign, which is moving to another whatever. Okay, EDI still has it. ESP has been overwritten with the memory address where it is. Wait. So first off, I want to check if EDA works. EDI, because that is still in the... This is an N sign, which is somewhere else on the stack and not in the... So an address that... So EDI. Yeah, EX EDI. I think I need to like select output. Okay. Override. Okay. Damn, that works. Because the ESI never got cleared. Store everything on the stack. Shellcode isn't just for exploit. Holy fuck, okay. Oh. That fucking works. So, because now I can also call it from the ESI, because that never gets cleared. Which I can patch that, but I need to do a pointer. So that should be a D word pointer, I think. EX with a D word PTR to ESI. Invalid instructions or prefix. D word PTR. Okay, that doesn't work. Wait. Invalid instruction or prefix. Wait. This is pretty funny that this actually works on the ESI, because the ESI hasn't been cleared, because it puts this D word blah blah local 8 into ESI, but the ESI never gets cleared in here. So this is why I am able to call it. But technically I should local 8 I wonder. EBP plus local _8. That shouldn't work because let me copy minus 0x4. Okay. Minus 0x4. So fetch instructions. It's gonna be EBP plus that, which is gonna be a lot of this. I don't think this is being cleared as well. Let's try save this. Underscore patch 2.x output. Okay. Which is patch 2. Nah, I just get bullshit in there. But this is funny because it is in here. Then it calls ESI. Then it does this call. And then everything happens, whatever in this function or shellcode, whatever this is, it's happening there. It's magic. But ESI is never been cleared, so technically I can just put in ESI in here. And then if it's been patched, shellcode isn't just for exploits. So it is nice to understand how you read the shellcode and do everything what I wanted to do. But it is also really nice to see that ESI has never been cleared. So patching things, maybe for whatever malware or something with patching. The only thing what I want to do is I need to figure out how to get wait, I patched ESI, right? No, EDI. So I patched EDI. Right. Wait, EDI. EBP, EX, EDX. Let's don't save. Go back to shellcode 1. Yes, analyze. Functions entry. So it's dword to local 0. Which dword to local 0, which I would point to what ESI is. Can I just do ESI? You can just do ESI. How do I... point to this with a I understand that. Pointer to ESI assembly. Is this oh, it's the destination, but the source index. How do I say? Notice that third uses EDI multiplied by 4 EVP. Okay. Destination address. So EDI, so this is the destination address where this is, but this is the source address. So how do I read the source address? ESP, what is ESP again? ESP assembly. Stack pointer. So it points to, yeah, right. Because that is in a stack. So where the stack is from EDP, that's where it is. But the source address and the, so at this destination is assembly get results source address ESI. Get ESI and EX. Something like this. This is not test, okay? Push add assembly. Every time I get this up here, Okay. How? 1 second. I need to sneeze. Oh. The memory address ESI into EX. Move 4 bytes to the data. It's 1 byte. No, that doesn't work. Ah, there's it pushing in 80. So and because EDI never clears, it keeps it there. And because it doesn't appear, That doesn't work. Just calculates everything and then it's in EDI. Oh, okay. I think I get it. I think I get it. So the shell puts the code, pushes it in EDI, but never clears it, and this is why I am actually able to keep it there. And we'll patch it. Okay. Interesting. All right. Yeah, I'm gonna quit the stream. I've learned a couple things, new things right now. Which is interesting. Hey, I was aim. Yeah, so I'm gonna quit the stream. Thank you so much for. Yep, I am actually going. I've been streaming for almost 3 hours, just learning how to patch and read how the shellcode works. I somewhat understand how it works. Yep. So hopefully we'll get better. But I need to go anyway, so yeah, I need to get up really early in the morning. And thank you so much for watching. Hopefully you enjoyed it. I did. Learn a couple new things within Ghidra and in, of course, X32 debugger. Hopefully I learned something that we'll learn more over time. But it's just too early. It's just 9 days for the things that I've been learning so far. So we'll see in the future. Okay, thank you so much, and see you later. Bye.
Swear I won't forget this, why do I regret this? In my mind reckless, thoughts are feeling endless. Sitting up, I'm breathless, anxiety's infectious. I feel so defenseless, betrayed and embarrassed. I hate being open, I hate being broken. I feel like an ocean filled up with emotion. Anger ain't a potion, rub it on like lotion. I can feel it soaking, reopen, the scars have awoken. I can't move on till I let go. I feel so lost, never at home. Need to be strong, every breath hold. Cause I can't move on till I let go. I can't move on till I let go. I feel so lost, never at home. Need to be strong, every breath hold. Cause I can't move on till I let go. I'm just lost to feel. I need time to heal. I can't steer the wheel, cause this drive to kill. And it gives me chills. A nice road it feels. I slip off the peel and crash all the steel. Will I ever heal? I can't move on till I let go. I feel so lost, never at home. Need to be strong, every breath hold. Cause I can't move on till I let go. I can't move on till I let go. I feel so lost, never at home. need to be strong every breath of, 'cause I can't move on till I let go.